we shall strictly be looking at balancing of chemical equation. In chemistry, balancing of chemical equation is highly important. A grown-up student in chemistry must be able to balance chemical equation accurately. How do you balance chemical equation? You see, the word balancing of chemical equation shouldn't be something that is big to you. It's just like you want to cook now, you want to cook rice, you must make sure you put appropriate salt in the rice you want to cook. Another ingredient, if you just, you need to just make it sweet. Everybody will like it. Exactly what we do in chemistry when we talk of chemical. How do we balance equation? The first thing, you know, 20 hydrogen to calcium. Having known those 20 elements, you now start thinking of how you can join them together so that they can form compounds. Compounds are actually useful products. They can be chemicals, they can be salts, they can be anything we use in our daily lives. So look at the way I want to do the balancing of chemical equation and listen attentively. You can see this periodic portion of elements that I have here. You see, these elements are group 1 elements. These are group 2 elements. Group 3, group 4, 5, 6, 7, 8. Group 1 to 3 elements except hydrogen. Group 1 to 3 elements except hydrogen are being written as single atom. The way they are in their symbols, the way they will participate in equation of reaction. But you see, this element from group 7, you see, of course, you know noble gases don't react. They have combining power of 0. So these elements here, we have them being written as 2,2. If you put F to react with lithium, it will be F2 we put, while lithium stays as lithium. And if it's chlorine, Cl2, oxygen, O2, nitrogen, N2. Now look at what we want to do as example. Write a balanced chemical equation of reaction between sodium and chlorine. You can see sodium, Na, is in group 1. So you write the symbol. It's going to be sodium. See? Then chlorine is going to be Cl2, as I've said. The product that this will produce, you see, is going to be sodium chloride. You see, to produce sodium chloride. Combination of sodium and chlorine is sodium chloride. Now, when you want to write the compound, it's compound, it's sodium chloride. You will now look at their combining powers. So the group 1 element combining power of 1. Then you have combining power from a noble gas which has 0. Then you have the combining power of group 7 as 1, group 6, 2. It comes like this: 1, 2, 3, 4. And this one, 1, 3. So you have your sodium combining power of 1, chlorine combining power of 1. It combines with this, is combining power. It combines with this one as a subscript. You see, it will now be NaCl. So it's 1, 1. You don't need to put it. Then you now be thinking of the coefficients. You consider the number of atoms at your left hand side and your number of atoms at the left hand side. This is sodium chloride. Now, how do you balance it? The number of atoms here must be the same as the number of atoms that we have at the product side. So sodium is having only 1 atom here or here. It's 1 atom. Here it is 1 atom. But look at chlorine. The subscript here is 2. You see, 2 atoms here, but 1 atom. Subscript here is 1. So what we do, you will not put 2 here because it's 2 here. No, don't do that. So in chemistry, we look for coefficients. Your teachers must have mentioned coefficients. So coefficient may be 1, maybe 2, maybe 3, you know, and be as I've written it. So now to make this one 2, whatever you put here will multiply the 1 here. So let's put 2 here now. Look at it. So that sodium will now become 2 and chlorine. 2 times 1, that is subscript here, makes sodium to be 2. Meanwhile, sodium is 1. You take care of here so that the 2 times 1 will be 2 sodium. Then chlorine 2 is 2 already here. 2 times 1 here, then is now 2 chlorine atoms. That is, this one now is balanced. Example shall be the reaction between aluminium and oxygen. You can see the question on the board saying write a equation between aluminium and to produce aluminium oxide. Now you will know the definition of aluminium. Of course, the symbol of aluminium is Al. You look at where it is, you see 3. So the combining power of group 3 elements, I told you the 3 because 3 is 2 group 3. Then you come here to talk of this non-metals here. At the combining power of this one, they won't start from these inert gases that are not reacting. They have 0. Then you have 2, 3, 4. So let us look at aluminium. You can see aluminium, Al. But before that, you write their symbols first. You understand? You use them as they are. Then it's the product that needs the combining power. So aluminium, how do we write it? You know it's going to stand as Al. No 2, no 3. I told you group 1 to 3, they stand the way they are. Then oxygen now, look at it. It's first here, like the first example that I said, F2, Cl2, O2, N2. That's how you write it. It should be O2. Then you now look at the combining power. The way we did the other time, aluminium is 3, oxygen is 2. So see, this it comes here as subscript to aluminium, while 3 comes here as a subscript to oxygen. So this one will now give us what now? Al, see 2 here, then O3. So the formula of aluminium oxide is actually Al2O3. So this is aluminium oxide. So our next example now shall be the one that has to do with, so we need to now balance it before we move to the next example. You can see that the atom here is just the symbol of aluminium. Then this one is the way I said those ones at that side will be written. It's 2 atoms of oxygen. Then we have Al2O3. Now you need to balance it. So you have to think of the coefficients you will use. I told you coefficients start from 1, 2, 3 to infinity. How many atoms do we have here? Of course, it's 1. How many atoms we have here? We have 2. Then we have 2 here. We have 3 atoms of oxygen. So let's see if we put 2 here, so the aluminium can be 2. Then Al2. Oxygen is now 3 and oxygen is 2. This is not really what we are looking for. So let's try 2 here and see. So 2 times 2, aluminium will be 4. We take care of aluminium here to be 4. See? So 4 atoms of aluminium. Then oxygen, 2 will still multiply 2. So we have 2 times 3 making, we have 2 atoms here. By the time we use, so it's balanced. 6 now, 6 atoms, 4 atoms, and it's the same thing as 4 atoms of Al and 6 atoms of oxygen. So it's balanced. Example we shall be looking at is reaction between magnesium and nitrogen. And it's going to be done exactly the way I've done the 2 examples previously given to you. Look at it now. Look at magnesium. You look at it. Look at magnesium position here. It's still in group. So it will be written as symbol Mg. See? Don't forget the elements between all of them are singly written when they want to participate in chemical. Don't forget chlorine, nitrogen, they are at 2 atoms. So it will now be N2. When you now want to form it, you think of their combining powers. Of course, combining power of Mg will now be 2 because of 2. And combining nitrogen from 0, 1, to now 2, 3 will now be 3. N is 3. So this one now combined with this one by giving this 2 to it as substrate, and this one comes here as substrate. So they will now combine to give us 3 from nitrogen 3, then from Mg to N is MgN2. You can see we have formed our very simple our magnesium nitride. Now you need to balance. I told you if you want to prepare rice, you have to put correct ingredients. If the salt is too much, problem. If salt is not enough, problem. So you need to balance it, just exactly what we do in chemistry class. Very simple. So look at it now. Mg is 3 here. I quickly look at which number will I put here. That will multiply this subscript 1 here. That will give me 3. So I put 3. So 3 times 1 is 3 now. I have 3 atoms of Mg. Then N2 of course is 2. Then is 2. So this is balanced. Very, very simple. Can't you see it? So this is our magnesium what? Nitride. So I think it's understood. Anything you don't understand, please kindly reach us in our comment section, and sit back always. Always be ready to watch Jokchem chemistry class. We shall always give